Vector plus vector resulting in. Thank you. Okay, so just some reminders with unit circle. The reason why we create this is because we can quickly pull cosine and sine values. Cosine is your x value, sine is your y value. Remember that all the angles that's closest to the x-axis, they're all reference angles of 30 degrees. So they're 30 degrees away from either 180 or 360. All the middle angles are 45 degrees away from the x-axis. All the furthest angles away are 60 degrees from the x-axis. Closest ones has close to the x-axis, and has a 6 in the denominator, 4 in the denominator for the middle, and furthest away with a 3 in the denominator. So if you are good with the first quadrant, the second, third, and fourth quadrant are just building off of those same order pairs. It's just that the signs are adjusted because of the quadrant that we're in. So you can some nice properties about radians is that all your numerator of your second quadrant are 1 lower than your denominator. So 2 and 3, 3 and 4, 5 and 6. Third quadrant, all your numerator has fractional values that's 1 higher in the numerator. So 7 over 6, 5 over 4, 4 over 3. And then the fourth quadrant, it's similar to second quadrant. It's except we have to make some adjustment here. So we have to multiply by 2 and subtract by 1. So 3 times 2 is 6, 6 minus 1 is 5, 4 times 2 is 8, 8 minus 1 is 7, 6 times 2 is 12, 12 minus 1 is 11. Basically, all your sine and cosine values are all, one of 3 things. It's either 1/2, √3/2, or √2/2. One of those, and then the signs are potentially plus or minus. Okay, so give you guys a chance to finish that up, and then I will quickly run through page 18, which we did yesterday. Make sure we're good with that, and then have you guys try page 19. Same process, and I'll work through the same time that you guys work through. Okay, so we're going to walk through page 19 together. Okay, so yesterday we talked about how to convert from rectangular to polar and also from polar to rectangular. So for 1 and 2, we knew that if you're given A and B, you can basically go to Pythagorean theorem to find your radius. And then your theta, if it's along the axis, it's easy because you know it's either 0, pi over 2, 3 pi over 2, or pi. But typically, if it requires a formula, we have to go through inverse tangents. And so number 2, we talked about how we wants theta in terms of radians, but the quickest way to do this is get it through degree mode. So if you go through degree mode, you can get to -60. You know it's in the 4th quadrant. -60 plus 360 is 300. Convert that 300 back in terms of radians. So you can either go through times pi over 180 or just recognize unit circle wise that 300 degrees is the same thing as 5 pi over 3. And then all you do is you take your r and your theta and you put it into the polar form for complex number, okay? Which you're just taking the r and the theta and you're putting it into this form, which is r cosine theta plus I sine theta, right? And that's what we did for number 2. Now, to get from polar form back to rectangular form, you just take that radius and distribute it through and get that cosine and sine back to ratios, and that will take us back to rectangular form. So that's what we did with 5 and 6. With 5 and 6, we just graphed at points. We know the theta is 120, that's second quadrant. Radius is 5, so we counted 5 units towards the second quadrant along that line, and then distribute that through cosine of 120. That's the unit circle value. Sine of 120. That's the unit circle value. Distribute the 5 through, and then we can get a rectangular form A plus BI. So that's a nice thing. I also want you guys to have that unit circle value, unit circle in front of you. That way, you can also use it to help you with this portion of it when we get to the back page. Okay, so we're just practicing with these concepts on page 19. So let's work through these, and I'll work alongside you guys as you guys try it. Again, make sure that you are identifying which quadrant you're in, right? You can look at that rectangular form and know exactly which quadrant you're in, and just make sure that whatever degree you find, that you adjust it back in terms of the correct quadrant. Now, after you get to your degree measure, bring it back in terms of radians, since it's asking for in terms of pi. This is right. Right, the polar form. So the polar form is this.
Oh, okay.
Yeah.
So
Yeah.
this is just the.
Our data is polar form for real numbers. This is the polar form for complex numbers. So.
Instead of comparing to radians, can you just put your calculator radian mode?
You can, but some calculators may not give you like some part for the way that you would like. So I say 2 degrees because the calculator will give you something that you recognize easier.
Okay.
Oops. Now, all these are unit circle values, so technically you could just use your unit circle value and look at sine over cosine and decide which quadrant it's in and be able to just go directly to radians. But if you want to use your calculator, I suggest degree mode since it gives you something that you recognize more easily than radians. Yeah.
Are we gonna get one of these all the times?
Yeah, I'll give you a blank one. Give you a blank one. Okay. Any questions with 1 or 2? Yeah, so I would suggest the first thing you do, name the quadrants. That way you always have a way to double check and make sure that you're not accidentally in the wrong quadrant and giving the wrong answer.
Are we gonna have like a calculator for?
Yes, you get-
Calculator for.
You get to have a calculator for the entire test. Okay, careful with this one. If you're entering this into your calculator to find your radius, make sure you put your 5√3 in its own set of parentheses. Otherwise, the square is not going to do what you want it to do. You need that square to see both the √3 and the 5. But if you leave the parentheses out, 2 is only going to see the √3, and that's going to give you a wrong answer. So you want to make sure you have those set of parentheses there.
why wouldn't 2 pi/3 be your theta value? So you do it the like unit circle, isn't, -1/, inverse tangent of -1/3, isn't that, pi/3? If it's units for 3.
1/3. Well, it's sine over cosine. So it's y over x. Any questions with 1 through 4 before I move on? Okay, so 5 through 8, you should find this a little bit more straightforward because you're just distributing the 3 through your trig expression, and then you're getting your trig expression or your trig values down to a ratio, and then you're just getting it into a plus bi form. Yes. Yeah. So here, if you want to be in radians, or you can just pull it from your unit circle, but yeah, it needs to be in radians if you want to use your calculator.
We're gonna have a unit circle.
I'll give you a blank one.
Okay.
Also, plot the point onto your graph.
Would it be in radian both ways?
Yes, radian mode. Yeah, anytime you see non-degrees, it's going to be radians. It's just a 1. Yeah, just a 1. Yeah, there's no, you'll see a number in front of the parentheses. It's a hidden 1 there. Okay, now, this is really the foundation here. The next 2 days, we're just going through addition and subtraction. So we're just taking these concepts and just putting it into a formula. But if you know how to get from polar to rectangular to polar, you're gonna find the next few days pretty easy. We're just building on top of the same concept. All right, I'll get your phone.
Yeah. Can you say like the inverse tangent? I like the inverse tangent with the extra law. Is it inverse tangent?
I just went to find out some holding it. Yeah, develop so that
Extra line?
No, it's not. Cotangent. Inverse or cotangent, yeah. So remember, inverse doesn't mean that we flip it, but it just means that we get theta by itself. Yeah, same thing, we're just solving for theta, we're just moving the tangent. We're not moving.
I got inverse tangent.
Okay.
Very good.
I forgot my notes.
It's so hot, there's so many people here.
It's unrelated to this stuff, but if you're like dividing